Hello folks, we come to the new chapter 5, continuity and differentiability, and right away we will start with the exercise 5.1. This is going to be our first question. In the first exercise we are dealing with several concepts in this chapter, and the very first concept that we are dealing here is continuity. Continuity means given a function, suppose if we happen to plot its graph, then the graph will be continuous without breaks. Okay, but every time when you're given a function, it is not possible to draw a graph and find out whether it is continuous or not. So we have got algebraic tools to determine whether it is continuous or not. Algebraic way of finding. So there's a way of finding the continuity depending on how the function is. So that we'll be using here. They have given several functions. We have to find out whether it is continuous or not. So the method of checking this, now let's see this question. It says that f of x is 5x minus 3. You have to check whether this is continuous at x equal to 0, x equal to minus 3 and x equal to minus 5. So the first case, x equal to 0, in order to show that it is continuous, which is that algebraic tool that we use, we have to actually show that, limit as x tends to 0 f of x is equal to f of 0. This is how we check. So since we already know limits, we have studied it last year. So limit as x tends to 0 f of x we will find out, and we will find out f of 0 by the function, and we'll check if the values are same or not. That's how we are going to do it. So right away we have got three subparts. We'll start with the first subpart where we have this. We'll consider this part, limit as x tends to 0 f of x, which means it is limit as x tends to 0 f of x is 5x minus 3. X tends to 0 means it's very close to 0 but not 0, but you can substitute the value. So what will come? It will come as 5 times 0 minus 3. The answer is, this is 0, 0 minus 3, answer is minus 3. We'll find out f of 0 and f of 0. Let's find, means wherever x is coming, there we are putting 0. So it's going to come as 5 times 0 minus 3. That is also minus 3. Therefore, limit as x tends to 0 f of x is equal to f of 0, which means that f is continuous at x equal to 0. At x equal to 0. Now this is the same idea we have to continue for minus 3 and minus 5. So gradually we will do it. The second subpart, we are supposed to show that a limit as x tends to minus 3 f of x is f of minus 3. Let's find this. Therefore, limit as x tends to minus 3 f of x. That is limit as x tends to minus 3, 5x minus 3. We do the same work there, 5 times minus 3 minus 3. So it's minus 15 minus 3 minus 18. And f of minus 3, same thing, 5 into minus 3 minus 3 minus 18. So both these are equal here. Therefore, limit as x tends to minus 3 f of x is f of minus 3. Therefore, f is continuous at x equal to minus 3. Now same thing we have to do for the third subpart, where we have to check whether x equal to 5 is a continuous point for the function. So to show that, limit as x tends to 5 f of x is f of 5. So therefore, limit as x tends to 5 f of x, that is limit as x tends to 5x minus 3. So tending very close. So 25 minus 3, 22. Therefore f at 5. Same idea, 5 times 5 minus 3, 22. Therefore, limit as x tends to 5 f of x is equal to f of 5. Therefore, f is continuous at x equal to 5. So that's about it. This is how we show the continuity. Now there is yet another definition of continuity depending on the fluctuation of this function fx. If the fx is a very fluctuating function, then we have another definition. Otherwise, we will use this one. Next question is, you have to check the continuity of this function at x equal to 3. So we have got to show that limit as x tends to 3 f of x is f of 3. So consider limit as x tends to 3 f of x. So 2x squared minus 1. So tending to 3, very close to 3. This is 9 into 2, 18 minus 1, which is 17. Now f of 3 is equal to, in the function, wherever x comes, there you put 3. 3 3s are 9, 9 into 18, that is also 18 minus 1, 17. Therefore, limit as x tends to 3 f of x is f of 3. Therefore, f is continuous at x equal to 3. That's about the continuity of this. Now we are going to the question number 3, subpart 1. Now here in the question number 3, they don't specify the point, they just ask us to find the continuity. That means we have to find the continuity for the whole real number line. And by taking a general point, we find out whether it will be continuous or not. That's what we are supposed to be doing. So let's check over here. F of x equal to x minus 5. Let a so because it is for any real number, so we will say that let any a belong to R. It's a real number. So here you have to show that limit as x tends to a f of x is f of a. This is what you have to show. So consider limit as x tends to a f of x. F of x is x minus 5. So that is a minus 5. X tending to a, very close to a, can be taken as a. So a minus 5, and f of a is a minus 5. So therefore, limit as x tends to a f of x is f of a, and therefore f is continuous at a belonging to R, which means f is continuous in R. At any point it will be there. In R it is continuous. That's all about this video. We have more problems to do that we are taking up in the next video. Thank you.